Good day to all of you. Let me acknowledge everyone who are participating in this GREE Photovoltaic Webinar. I'll be your resource speaker for today, Engr Roberto Rosales. Designing HVAC and adhoc system on MEPF for 32 years now and have been exposed to all types of industry, providing design, construction, property, and facilities management as well. The task requested by Unitech Philippines for me is to share some of my actual design experience under GREE Photovoltaic Chiller, which I professionally designed, supervised, and collaborated with them in terms of MEPF consultancy works from design, construction, and operation, including some collaboration works with distribution utility company that cover the project site. There are 12 things you need to know when designing for GREE photovoltaic chillers. Please sit back and relax for your new learning. GREE Photovoltaic Direct-Driven Inverter Centrifugal Chiller is the world's first photovoltaic central HVAC system. It's the first to seamlessly integrate power generation and power consumption together between clean energy and grid-connected air conditioning system. It provides you with a solution for energy-saving equipment as well as clean energy and intelligent management in one chiller package. In a typical photovoltaic system installation, number one, innovation and utilization of photovoltaic power and grid-connected power. To maximize utilization, it will require installation of PV inverter. That's a typical photovoltaic system installation. I remember when we installed several PV panels in one of the office building in Makati, we tie it up directly to the grid, which requires PV inverter. The savings on power is realized through building net metering system. With the first innovation on ternary commutation or triple substitution technology and the PV converter function, GREE Photovoltaic Direct-Driven Inverter Centrifugal Chiller is the first of its kind central air conditioning equipment that integrates power generation and consumption together in one. It uses technology that can switch to 5 different working modes according to the condition of power generation and load demands. The switch between each mode takes less than 10 milliseconds. Therefore, unit can realize a seamless connection with power line or utility company and maintain stable operation. It adopts the permanent magnet synchronous motor direct-driven inverter centrifugal chiller to ensure high efficiency whether at full load or partial load and provide an estimated savings of more than 20 to 40% of energy compared to common centrifugal chillers. As power is supplied by the PV system, this centrifugal chiller is highly efficient and can provide energy saving both on grid and off-grid conditions. Number two, it uses intelligent control to track down maximum power utilization, whether on solar or grid connection. MPPT, or Maximum Power Point Tracking Technology, is raised to deal with the unstable voltage of photovoltaic power. With MPPT control, combined with AC and DC commutation technology, system doesn't need the AC-DC constant voltage modulation that traditional photovoltaic air conditioner would need. Actually, it can track and control the real-time photovoltaic power generation to its maximum so that photovoltaic power can be best utilized by the centrifugal chiller. Number 3, it enhances energy management through its 5 system operating modes. By utilizing PV electric current to directly drive the centrifugal chiller and by distributing power through the power generation and consumption integrated system, the utilization ratio of PV power is approximately 99%. Besides, system efficiency is increased by 6 to 8% higher as compared to combining grid-connected PV system and air conditioning system. According to the operating condition of PV system and centrifugal chiller, it can switch to 5 different working modes as regards to power generation and consumption. Actually, the switch between each mode takes less than 10 milliseconds. Number 4, the GREE PV chiller is capable of grid-connected power. When the control panel displays pure AC mode, it indicates that the unit draws power from the power line or utility company instead of the PV system. In this mode, PV system is entirely isolated and unit become a typical direct-driven inverter centrifugal chiller. Number 5, the integrated management of GREE PV chiller can allow solar power to serve the online power grid, thereby providing energy savings through net metering system. When the chiller controller display indicates pure photovoltaic mode and the GREE chiller is not working, then the PV power generated can be supplied directly to the online power grid. In this GREE PV chiller integrated energy management, it will function as a current converter and PV system will become a power station connected to grid, thereby providing savings, and it's realized through building a net energy metering system. This condition happens during the time that the chiller is not operational, specifically during daytime period before a commercial mall starts its operation, that is between 6 a.m. to 10 a.m. Number 6, the GREE PV chiller can source its power entirely from solar panel. In the PV-AIRCON mode, it indicates that the mode where all the power generated by the PV system is used for GREE PV chiller units operation. Please keep in mind that the PV system design capacity will deliver an average 15 to 20% of its total capacity to any GREE PV chiller. Number 7, with its integrated current converter or energy management system, simultaneous power generation and consumption is handled seamlessly within 10 milliseconds. In this mode, some of the power supplied by the PV system is used for GREE PV chiller units operation, while the excess power is supplied to the power line. The installed integrated monitoring system will display the PV-AIRCON-POWER gen mode when power generated by the photovoltaic system exceeds the requirements of the GREE chiller, and this can happen during part load performance of the chiller. Number 8, with its integrated current converter dual power source for chiller is possible simultaneously. In this GREE PV chiller unit, needs to draw power from the power line in addition to the power supplied from the PV system. The integrated monitoring system display the PV aircon power consumption mode when power generated by the PV system is less than the power consumed by the air conditioning equipment. This condition can be observed when the load profile of GREE PV chiller is at peak, but the weather condition is fair. Number 9, it utilizes the GREE patented 5 core technologies. In layman's term, the use of inverter chiller address part load performance and provide better efficiency for central air conditioning system. Ternary commutation deals with switching technology between solar power and online grid connection of chiller. MPPT technology pertains to power tracking of solar power generated by the PV system, as well as manage any unstable power delivery by the photovoltaic system. Item 4 and 5 focus on synchronized and parallel operation between two sources of power, the PV power and the online grid power. Number 10, solar panel can be sourced from your trusted manufacturer and can be connected directly to GREE PV chiller. If you have pre-selected PV manufacturer or supplier from different parts of the world, they can collaborate directly with Unitech for GREE integration works on your existing PV system. Number 11, Unitech Philippines offer design collaboration for integrated design for your office building, commercial development, and industrial facilities. I'm sharing with some of the chiller installation specification details I've used in designing the several new Unitech malls nationwide. I've used 300 TR and 600 TR chiller specs. It could save much of the construction work as well as the installation area. It can be widely used in large office buildings, hospitals, schools, shopping malls, and industrial processes, or used to reconstruct the building installed with the PV system and air conditioning so as to improve operational efficiency. It is exceptionally energy saving, intelligent unit or equipment, adaptable and highly integrated system. Number 12, typical application can utilize your existing PV installation or provide your independent PV system for Gree Photovoltaic Chiller. We made some comparison for building with photovoltaic panel dedicated for Gree PV Chiller as shown on System 2. Given its estimated system capacity of 489 kilowatt power, system capacity can generate 156 TR. Pre-cooling, and a designer can specify the use of 800 TR Gree PV chillers. For a typical industrial facility that uses photovoltaic panels or lighting, for a typical specs of 500 kilowatt system capacity, designer or consultant or developer can use 850 TR Gree PV chiller, and this kind of specification can provide free cooling of approximately 163 TR. Please keep in mind that the maximum power drawn from a typical panel ranges 15 to 20% for an average of 17% power generation. Some bonus points. Design consideration on the use of direct-driven inverter centrifugal chiller. Designer, consultants, and developers can benefit on utilizing this GREE PV chiller, even if it is being used as a typical chiller for the facilities without the connection of photovoltaic system. Because of its high efficiency compressor, ranges from the smallest chiller of 300 TR with kilowatt per ton of 0.58 up to 1,000 TR with kilowatt per ton of 0.506. In the three most that I was able to design for reruns realty, the Unitech Paliparan in Dasmariñas, Cavite, I designed 3 units of 600 TR GREE PV chiller. And in Unitech General Trias, I think I designed 3 units of 300 TR GREE PV chiller. And also in Unitech Ligan, I think it has the same capacity with General Trias. Yeah. We can share the design for this with usage you need for your development. Actually, Unitech offers collaboration works for clients who are interested with this GREE PV chiller. Additional notes, tech on PV panel installation. In excess of 100 kilowatt production in solar power generation, you have to secure approval from DOE and the National Renewable Energy Board and your distribution utility company. You can get your own PV supplier and GREE will connect it to chiller system. PV panel is not proprietary with GREE, so you can buy from your reputable source. And also RA 9513 is the applicable laws for this, or we also known as the Renewable Energy Act. And we would need also the approval of DOE and ERC and your distribution utility company. I believe there was an IRR under approval for the net metering being provided by ERC. For large developer, it's good also to know the DOE Circular DC 2017. It pertains for retail competition and open access memorandum. Some references that worth considering when you're designing for GREE PV chiller. Thank you very much. I hope you have learned with this GREE Photovoltaic Direct Driven Inverter Centrifugal Chiller Webinar.